In this presentation, we will take a deeper look into analyzing motion. We will learn how to use the slope of a v versus t plot to find acceleration and learn how to identify a constant acceleration plot. Before we continue, we need to review the definition of acceleration. Acceleration is the time rate of change in velocity. It can be calculated by dividing an object's change in velocity by the change in time. Many objects in this world move with what's called uniform acceleration or constant acceleration. Let's review what uniform acceleration means. Only the data on the left shows uniform acceleration. It always changes by 2 meters per second each second. The velocity on the right increases the entire time, but not by the same amount. The data shows uniform acceleration because every second the velocity changes by the same amount, 2 meters per second. Since the object increases its velocity by 2 meters per second each second, its acceleration is positive 2 meters per second squared. Describe the acceleration at regions A and B. During region A, the velocity of the ball is constant, so the acceleration is 0. When the ball goes up the hill, it moves with uniform negative acceleration, and when the ball rolls down the hill, it moves with a uniform positive acceleration. Another word for uniform is the word constant. Describe the acceleration of the ball on the way up and down. When a ball is dropped, it falls down with a constant positive acceleration, and when it moves upward, it has a uniform negative acceleration. Objects move with a constant acceleration in the presence of a constant net force. When you stop pedaling on your bike and coast to a stop, you are moving with constant negative acceleration. When you ski down a mountain that has a constant slope, you do so with a constant positive acceleration. Where in this plot is the acceleration 0? Since acceleration means the rate at which velocity changes, we can see that there are 2 places where there is no change in the velocity. Between 7 and 10 seconds, the object maintains a velocity of negative 20 meters per second, so the acceleration is 0 there. Between 11 and 14 seconds, the object maintains a velocity of 0 meters per second, so the object is at rest and the acceleration is 0 there as well. Where in this plot is the acceleration constant or uniform? Since constant acceleration means the velocity changes by the same amount each second, the acceleration is uniform or constant during each interval. Rank the accelerations from greatest to least. Before you pick the greatest acceleration, remember that in physics, negative values are not greater than positive values. The interval where the velocity changes by the greatest amount is between 10 and 11 seconds. In only 1 second, the velocity increases by 20 meters per second. There are only 2 other time intervals where the velocity is changing. This is between 0 and 3 seconds and 3 to 7 seconds. The second biggest acceleration is between 3 and 7 seconds. It has a negative acceleration of negative 10 meters per second squared because it decreases 20 meters per second between 3 and 5 seconds. The next greatest acceleration is the next greatest slope. That occurs between 0 and 3 seconds. The fourth greatest slope are the 2 regions that have no acceleration. That's between 7 and 10 and 11 and 14. Watch the velocity in this speedometer change. Is it constant or non-constant acceleration? Notice that the velocity increases slowly in the beginning and quickly at the end. This is not constant acceleration. Describe the acceleration in this plot. When we do the y-axis analysis, we see the velocity starts from 0 and increases the entire time. Now let's describe the acceleration. Is it constant or non-constant? Since the velocity increases by the same amount every 2 seconds, this plot shows constant positive acceleration. If we use the acceleration equation, we get an answer of positive 7.5 meters per second squared. The slope of any v versus t plot, or velocity versus time plot, can be used to find the acceleration. Since slope is delta y over delta t, when you apply that to a velocity versus time plot, it's delta v divided by delta t. Whenever you analyze a motion plot, you look at what is happening to the variable on the y-axis. We see that the object starts at 30 meters per second and maintains that speed the entire time. Since the velocity is not changing, the acceleration is 0. Let's rank the acceleration of the four objects in this plot from largest to smallest. Since the slope of a velocity versus time plot is equal to the acceleration, the greatest acceleration is d, then the next greatest is c, b is the third greatest, and a is the last with an acceleration of 0. What motion does this plot show? The y-axis analysis tells us the velocity starts at 55 meters per second and ends at 0 meters per second. Since the velocity is decreasing, the object has a negative acceleration. Now let's look at the slope to determine the object's acceleration. Since the slope is constant and negative, the acceleration is constant and negative. Now let's use 2 points on the line to calculate the slope. The object loses 30 meters per second in 6 seconds, so it's negative 5 meters per second squared. In this presentation, you learned that when you see a straight line in a v versus t plot, you know that it shows constant acceleration. You can use the slope of a v versus t plot to find acceleration. This is the end of part 1 of my presentation on complex v versus t plots.